All right, continuing our reset day with another optional question that you can take a look at especially if you want to look at one that is a curve analysis type question, which is what this one is. This is 2012, number 3. It also has a little bit of integration, area under the curve. I feel like I've been making so many of these videos. I'm not going to know what to do when I'm in front of actual live people. My son told me today that I'm officially a YouTuber because every time he comes to the basement, I'm talking about math. So here we go. Question number 3. So I like to start these questions out by writing a little kind of key off to the side. And I think now you've seen a decent amount of these. Hopefully that becomes more comfortable. So if they tell you that g is equivalent to the integral from 1 to x of f, that means when I derive g, I get f because the derivative and the integral will cancel. Your variable now takes the x, which was the boundary, becomes the variable of f. And then if I derive again, g double prime will be equivalent to f prime. And I like just kind of putting that off to the side and knowing that I'm going to have to refer to it on and off throughout the question. So they tell us in the problem that we have the line segments, we have the semicircle, and then they give us this g equation. Part A wanted to know g of 2 and g of negative 2. So g of 2 and g of negative 2 are putting those numbers into the integral boundary. So I actually did my work up here for A to make sure I had enough room to do the rest on the bottom. So I'm integrating from 1 to 2 of f, which means I'm looking at this tiny little triangle here from 1 to 2. It is a triangle that has a base of 1 and a height of a half. And the way you'd figure that out is I kind of checked the slope just to see what's going on here. And what I saw, it has a slope of negative a half. So for every 1 down, it's only going over a half. So therefore, my value for that would be a 1/2 times 1 times a half. It is negative because of the location. So you end up getting negative 1/4 for your answer there. For g of negative 2, well, now you have an integral from 1 to negative 2. First thing you'll notice is your boundaries have been flip-flopped because your higher boundary should be on top and it's the opposite. So whatever I get, I need to negate it. So going from negative 2, I drew a line here to show where negative 2 was, and to 1 would be the end of the semicircle. I have a triangle here, 1/2 base times height. My work's over here. So 1/2 base of 1, height of 3 gives me an area of 3/2. And then for my semicircle, it would be a 1/2 pi r squared. R is just 1. So you end up getting a 1/2 pi, or pi over 2 for that area. It is negative because it's under the axis. Now, when I put those together, because my boundaries are switched, I actually need to flip them. So instead of a positive 3/2 and a negative pi over 2, I should have a negative 3/2 and a positive pi over 2. So here's my answer, and they would accept really any order that you write this. Negative 3 over 2 plus pi over 2, you could write it with a common denominator. Since it already has a common denominator, you could keep it separate. So for your scoring, they gave, I think, 1 point for each. Yeah, 1 point for the g of 2 being negative a fourth, and 1 point for the g of negative 2 being, again, anything equivalent to the opposite of this, or you could leave it as the opposite and put in parentheses. As long as you have something equivalent to that, you get the second point. So then it really starts getting into a curve analysis question. So let me go back to mine. Part B wanted to know g prime of negative 3 and g double prime of negative 3. So I wrote a little note here. G prime is the same as f. So if I'm taking g prime of negative 3, I'm actually asking for f of negative 3. That's going to come straight from the curve. F of negative 3 would be right here in the middle of that segment. You can check the slope of that segment to make sure it is going up 1 every time, so up 1 over 1. So that would be a height of 2. So that's your answer for that one. G double prime of negative 3 means f prime of negative 3, which in context of the picture means what's the slope of the function at negative 3. So again, my slope I go up 2 over 2, so I have a slope of 2 over 2, or 1. Which is all you need for that and really not much work. So scoring wise, I think it was 2 again. Yeah, 1 point each. So if you got 2 for your first part for g prime of negative 3, and if you got 1 for g double prime of negative 3, those are 1 point each. Obviously, you don't have to get both. You can get one of them right and get 1 out of 2 points. Then for part C, now it wanted to know the x coordinates where it would have a horizontal tangent line. Horizontal tangent line means 0 slope. This is horizontal tangent line. And then once we figure out what these are, we have to figure out, are they minimums, maximums, or nothing at all? So you're essentially finding critical values and then checking to see if the critical values end up being extrema is another way to phrase that question. So for part C, if it would have a horizontal tangent line when the derivative of g is 0, which means, since my picture g prime is the same as f, that means when does f equal 0? So going up to my picture, f equals 0 anytime it would cross or touch the axis. So it happens at negative 1 and it happens at 1. So that's the first thing I listed was my possibilities. These are essentially critical values. And then for each one, I need to check and see, does it change signs? Does it have a derivative that goes from positive to negative or negative to positive, or does it keep the same sign? So that's going to come from location. So above the x-axis is going to be a derivative that's positive, below is going to be negative. So at -1, it goes from above to below. What that means is the derivative goes from positive, meaning on the increase, to negative, decrease. So that's going to be a maximum. And I'll show you how I wrote that. I wrote has a maximum because the derivative switches from positive to negative. Best way to explain to someone if there's a maximum and minimum is talk about the sign change of the derivative. Now at 1, it doesn't change signs because it stays underneath. So what that means is it's actually negative before and after. So you don't have a derivative sign change. So we would say it's neither a minimum or maximum for that reason. You could say it's always negative around it, or you could just say it doesn't change signs. So for their scoring, they gave 3 points. The first point is basically the consideration. What are you looking for? You're looking for a derivative equal to 0. Even if you're not sure where that happens, even if you write down that horizontal tangent lines when the derivative equals 0, you give yourself a point. Your second point is that you realize the 2 places where that happened, and you would need both of these to get that point. And then your third point is your answer as far as minimum, maximum, and your justification. So there's a lot that goes into that third point. You do have to have all of that to get that point. So you have to say that there be a maximum at -1 and explain why, and then neither at 1 and explain why. And then finally, the last thing you were asked to do was talk about points of inflection. And they usually go in this order with when they ask you to do a curve analysis. So a point of inflection means the second derivative would have to equal 0 or undefined. And you're looking for a place where the second derivative sign changes signs. So you're looking for a second derivative that goes from positive to negative or negative to positive. So when you do a curve analysis, this is going to be anywhere that you have an extrema of the derivative graph if you're trying to find points of inflection. So here at -2, that's a possible point of inflection. At 0, I forget this one all the time. So if you totally buzz past this, you're not alone. 0 would be a possible point of inflection because it has that minimum. And then 1 would be a possible point of inflection because it has that maximum. We have places here where we have a 0 or an undefined slope. So when you list your options, -2, 1, and you can see I put 0 at the end because it totally was an afterthought. And then to explain if it's a point of inflection, you're looking for a sign change. Visually on this graph, in order for the second derivative to change signs, that means the picture, the first derivative of the picture would change signs. You need to go from increasing to decreasing, so a change in slope, or decreasing to increasing. And it actually happens for every single one. At -2 and at 1, you have a double prime switching from positive to negative because it's going increasing to decreasing. Same thing here at 1, increasing to decreasing. At 0, it does the reverse. It was decreasing before it got to 0 and increasing afterwards. So all 3 end up being points of inflection. Let me see the scoring on this. So your answer is essentially just listing those 3 values, -2, 0, and 1. And your reason can be very simple. It's just a sign change of the second derivative, or you can mention that G double prime and F prime are the same. You can even say how it changes signs. I will be honest, I would not have got full credit on this one because I forgot about 0. I had the explanation. I think I would have got 1 out of the 2 points because I had 2 of the 3 points and I explained properly, but I would not have got full credit because I forget 0 all the time. So again, 8 out of 9 is an excellent score. So go ahead and figure out how you did on that one. Again, I don't need a score report here because it was optional, but I think it's another nice one to look at as we're getting really close to that test. So if I find other good ones, I might put a couple other optional ones, but for now, I think we've got a little bit of everything. Tomorrow, I'm going to start posting the last couple that I want you to do for a score report, and then you'll be ready. Talk to you later.